breaking the wall of early cancer detection. Sara Hassanpour Tamrin, Falling Walls Lab, Edmonton.
Hello everyone, let's take a breath and let it go. Ready? It typically takes 3 seconds. Did you know that every 3 seconds, every time that we breathe in and out, someone dies of cancer in a world? That's a heartbreaking story, but we can change it. Evidence shows that when cancer is diagnosed early, there is a time to start a proper treatment, and survival rate increases more than 90% in many cases. However, most cancers are being diagnosed very late. The issue is that current diagnostic tools are not sensitive enough to find cancer signs in our body at the earliest stage. Some of them are very expensive, some of them, like tissue biopsies, are not comfortable for patients to use it regularly as a routine checkup. Of course, we need a more convenient method, like a blood test. In a typical blood test, a couple of milliliters of blood will be collected to look for cancer signs, which can be some metabolites or biomarkers released from cancer cells. But the issue is that quantities of these biomarkers in our blood at the earliest stage of disease is really low to be detected accurately. What we need is a novel technology or a novel biomarker. And today I want to introduce the game changer, exosense. Exosense is a novel technology that looks for exosomes, novel biomarker. Exosomes are super tiny particles in nanoscales released from any type of cells and contain some information from the cells, like RNA and DNA. This information provides a snapshot of the cells and can tell us if the cells are healthy or not. After release, we can find exosomes in our blood, urine, saliva. They are everywhere in our body. But the point is that when exosomes are coming from cancer cells, the quantities in our blood at the earliest stage of disease is really high compared to other biomarkers. And if we have a technology to detect these cancer-related exosomes, then we have a chance to find cancer early, just by testing 1 drop of blood. In our lab, we discovered that the content of exosomes can be reflected into their electrical properties, like surface charge. We found that the charge of exosomes, when they are coming from cancer cells, is significantly higher than normal cells. And exosense, this palm-sized device, which is a prototype that we typically make in our lab, is composed of multiple electrodes to look for those electrical signals coming from cancer-related exosomes. If the signals is detected, there is a LED, and it will turn on as a sign for detection of cancer. The technology is super cheap. Just a few dollars is the cost of this technology. And it's easy to use, which makes it accessible and affordable for everyone around the world. We are testing the technology for different types of cancer to bring the technology from the lab to the market, with this hope to be able to detect cancer early when there is a time to start a proper and effective treatment.